Simplifying expressions with roots. Powers and roots or radicals are opposites of each other. And I wrote basically opposites of each other, but they are literally opposites of each other. So that means that the square root of 5 squared is equal to 5. The square root of the square of a number, essentially what they do is cancel each other out. But we can also prove this, so I'm not just going to put crosses through things to prove math, but 5 squared is 25, and we know that the square root of 25 is 5. So these operations are opposite. So whatever one does, the other undoes it. So for 17 cubed, I don't need to cube 17. The cubed root of 17 cubed, well, the cubed root undoes whatever the cube does. So that's just equal to 17. So now if we have a radical expression with a variable in it, like the square root of a squared, we know that the square root of a squared, these are going to cancel each other out or undo the operation of the other. So simplified, this would be just a. When we're simplifying radicals, we can only take out the square root of perfect squares or the cubed root of perfect cubes. Let me show you what I mean by that. So we're going to simplify the square root of x to the power of 6. So to do this, we need to think about how we would cancel out a square underneath the radical. Well, let's do it by writing x to the power of 6 as some kind of square. And from our exponent laws, we know that x to the power of 3 all to the power of 2 would give us x to the power of 6. So that means that the square root of x to the power of 6 is the same as the square root of x cubed squared. So now we can see that the square root is going to nullify the square that's inside of the square root, leaving us with just x cubed. Let's go through the same thing for the cubed root. If I want to cancel out something inside of a cubed root, I need some kind of cube here. So how do I get a cube there? Well, I'm going to try y to the 18. Is there a cubed root in there somewhere? And sure enough, there is. I could write that y to the power of 6 cubed gets me y to the power of 18. So that's y to the power of 6 cubed. Now I see those that cubed root canceling with the cube, and so this is equal to y to the power of 6. So we can use our exponent rules to simplify these radical expressions. We can also simplify radical expressions if there's a coefficient in front of the variable. And the process is going to be the same. So if I want to simplify this expression, I'm looking for basically something squared inside. So 64 I could write as 8 squared, and x to the power of 8 I could write as x to the power of 4 squared. Now I've done these two things separately because that makes my life easier when it comes to doing the math in my head. But when we have two expressions squared, we could write this as 8x to the 4 all squared, because again, we know from our exponent laws that the power of 2 would be applied to both the 8 and the x to the power of 4. So what I've done is I've written 64 times x to the 8 as 8x to the 4 all squared. Now my radical is going to nullify my square underneath the radical, and I'm left with 8 times x to the power of 4. So my expressions are getting a little bit more complicated, but my method is similar. For this one with a fourth root, I don't have any fourth roots memorized, so I'm going to have to use my calculator to help me out a bit and think, is there a fourth root in 16? And sure enough, there is. 2 to the power of 4 is equal to 16. So I know 2 to the power of 4 is, or I can rewrite 16 as 2 to the power of 4. That's going to help. And then how about y to the 28? So can I write y to the power of something to the power of 4? Well, y to the power of 7 would do that because 4 times 7 is 28. So now my radical really looks like the fourth root of 2y to the 7 all to the power of 4. And now my radical, my fourth root radical, is going to nullify that fourth root that's underneath the radical, leaving me with 2y to the power of 7. If we have more than one variable, like in this example, simplify the square root of 36 x squared y to the fourth, it doesn't really change the process. We just try the same thing. This time I'm going to group a whole bunch of things together. So 36 squared, I could write that instead as 6 squared. And x squared, I could write that as just x squared. And y to the power of 4, I could write that as y to the power of 2 squared. So really, 36 x squared y to the 4 is just 6x y squared, all of which is squared. And now my square root and that square cancel, leave me with 6x y squared. Let's try the same thing with the cubed root. 216 is not a cubed root I'm familiar with, but let's use our calculator to check. The cubed root of 216 is 6. So sure enough, I could write this as cubed root of 6, and then I'm going to write some brackets with everything cubed. And how about m to the power of 9? I could write that as m to the power of 3 cubed. And n to the power of 12, I could write as n to the power of 4 cubed. So again, I can now cancel my cubed root with the cube that's inside of that root, leaving me with just 6 m to the power of 3, n to the power of 4. And, oh, sorry, I've made a big mistake here. Can you see where I've messed up? I forgot about my negative sign. So this is negative 216, which means that the negative 6 cubed gets me negative 216, or the cubed root of negative 216 is negative 6. So I need a negative in my answer. This is negative 6, m to the power of 3, n to the power of 4.